Hi, welcome to this video on energy. Specifically, we're going to be talking about work today and what it is and how to calculate it. Thus far, we've talked about forces and equations and about how to calculate acceleration or how to find distance, what we do, but we haven't talked about a very practical reality. Imagine you're pushing on a fridge or a filing cabinet or whatever you imagine this to be, and you're applying a force. As we know, applying a force that is unbalanced will cause it to start accelerating. But what we haven't talked about is how that changes with distance. Because applying a force to move it, say, half a meter, is a lot easier than applying a force to move it a full meter or more. The process of applying a force over a distance takes it out of you, it tires you out. In this process, this applying a force over a distance is what we call work. In this case, the distance you travel, or the displacement more specifically, tires you out and causes long-term issues. Let's talk about how we can calculate this. We already know how to calculate force. We can either find it via numerical values or we can calculate it using one of our equations. mg for force gravity, mu Fn for force friction. Or we could use sum of all forces to get pretty much anything else. But what do we do for work? Well, it's actually fairly simple. Work is the force you're applying times the displacement. We use d for displacement here for no particularly good reason, but it's what's listed on the AP exam, times the cosine of the angle between them. What I mean by this is that force applied in this angle is going to the right, as is your displacement. Since they're both going to the right, the angle between them is 0. Whereas the normal force is pointing up. This box, filing cabinet, whatever, is moving to the right. So the angle here between the direction it's heading and the direction of the force is 90 degrees. Friction, on the other hand, is completely opposite. Object's moving to the right, friction's moving to the left. So the force is pointing this way, but the displacement is this way. This angle here is 180. And again, gravity, you can think of it in one or two ways. You can go all the way around. Typically, the way this is thought of is the shortest path angle. So from here to here would be your angle. Because cosine is a even function, if you put in 270 or you put in 90, you'll get the same answer regardless. I'll typically use 90 because it's the shortest path. Now, if you remember anything about cosine, cosine looks something like this. And that is at 0, cosine equals 1. At 90 degrees, cosine equals 0. So what that tells us is that any force acting at the right angle must be doing 0 work. So the force gravity and normal force in this situation are doing no work. Friction is going the opposite direction. At 180 degrees, your value is -1. So friction's doing negative work. Well, what does that mean? How do we find that? Well, we'll talk about that in a bit. The important bit here is to understand that any force acting perpendicular to the direction of travel
does no work.
I can hear you ask, what about forces acting at angles? What about this force here, the force applied, where you're pushing up slightly to help reduce the friction? Well, if we break this into components, like we did the entire previous unit, the part of the force that lies along the direction of travel, or this chunk right here, is the x value, or the F applied in the x direction. If we go back, F applied x, F applied equals cosine theta. Again, at this point, it's just the chunk in the x direction. This is actually where that cosine comes from. It's how we can find the portion of the force that is in the direction of travel to find your amount of work. With that said, here we have a simple free body diagram for what's going on here. I've labeled the force applied. What I want you to do, find force gravity, find force normal, find force friction, and then find the work each force
Does.
individually. So find the work that force normal does. Find the work force applied does. Find the work force friction does. Find the work force gravity does. Go ahead, give it a try. Check back after the pause. Okay, let's take a look at some answers. I've put all the values up for each of the calculations. You'll notice my unit here is a J. That is a joule. Joule. A joule is a derived unit, much like a Newton, because we have a Newton here times a distance, which would be in meters. Cosine of an angle
Is dimensionless.
so this will have no unit. So we have a Newton times meter. Well, a Newton is a kilogram meter per second squared times a meter. Multiply these together, and we find that 1 joule equals 1 kilogram times meter squared per second squared. Now, I've gone through and calculated all the forces. The force applied was given to me. The normal force was this 1960. I found that by finding my force gravity, which is m times g, and then knowing that these two have to be equal. And then for my force normal, I can find my force friction by mu, which is the 0.41, times Fn, which gives me the 803.6. Once I have each of these forces, I can go through and calculate individually how much work each force does. For the normal and the gravity, it's really easy. 1960 times 7 times cosine of 90. Cosine of 90 is 0. 0 times anything is 0. That means that the normal force and the force gravity both do 0 joules of work. This idea that the force must cause the displacement or work against the displacement is very important. If the force does not have a component or part in the direction of the displacement, it will do no work. It is not causing that displacement. The force applied, on the other hand, definitely does. 950 times 7, and then the angle here is 0 because it's heading directly in the direction of travel. They're both pointing the same way. So my angle here is 0. Friction, on the other hand, is a 180, which gives me a negative 5625.2 joules. In other words, the force applied is causing the displacement, it is aiding and assisting the displacement, whereas the frictional force is opposing it, doing negative work. As a quick summary, we've talked about what work is the product of force in the direction of displacement and displacement. We've talked about the units of work, which are joules. We've talked about how to calculate it, how to find it. We've also talked about how to determine the angle. If the force and the displacement are the same direction, your angle is 0. If they're perpendicular, it's 90. If they're opposite, it's 180. And if they're in between, all you need to do is look at the angle between the two vectors, the displacement and force vector, to find your angle. Thanks for watching. Have a good day.